everyone, and welcome to Dev Show. I can see that we have a very new tune. Did you do anything, Rasmus?
Yeah, I was playing it myself, so it sounded very, very nice.
So great. So welcome to this very special edition of Dev Show. My name is Sherry Liz, and I'm your host today with my good colleague and musician Rasmus Jack. So,
Exactly.
so Rasmus, what else are you doing today? How's
Yeah,
life?
other than playing music to our intro, I'm yeah at home still, working from home. But the weather has changed in Denmark. So talking about the weather, it's almost 10 degrees now compared to last week where it was minus 10 degrees. So it's switching a bit here.
Yeah.
I was out running this morning and had way too much clothes on. So
Mm.
what about yourself?
I'm speaking of running. So if I want to be honest, I don't run so often, but I bought a new gadget, which hopefully is going to make me to move a little bit. I got a Nintendo Switch Ring Fit. So, and if I want to be very much honest, I'm looking forward this show to over so I can go and set it up.
So next week we are gonna hear how it went with your Nintendo Switch. So
Yes,
we look forward
I
to that.
hope. Yes, I can give a report about that.
Yeah, definitely.
So, to our audience out there, um, I want to inform you, actually remind you all that you can ask us a question from the speaker, and doesn't matter if you're watching us from Twitch, YouTube, Facebook, or Learn TV. You can send your question, and then we are going to get Michael, who is our speaker, going to answer to those questions. And speaking of engaging with each other, thank you, Rasmus. We have a code of conduct which is listed on our main meetup page. I really encourage you all to familiarize yourself with that code of conduct. But in short, we just want you to be mindful and kind to each other. So, Rasmus, what do we have on our agenda today?
Yeah. So today we have Michael. So Michael is gonna tell us about RepoDB, which is a hybrid ORM library for .NET. So that's going to be pretty exciting. And in the session today, we're going to learn, of course, what is RepoDB and ORM, and Michael will tell us even more about what's in this session, but also different features within the RepoDB, and then also why we should use RepoDB. So it's going to be interesting, and I don't want to dive deeper into it because I don't know anything about it, but I look very much forward to learn something new today.
Yes, same here. So let's bring Michael actually on the stage. So
Yeah,
hi,
so
Michael.
welcome to Dev Show, Michael. How are you?
Good. Thank you, Cheryl and Rasmus.
Amazing.
Yes.
Amazing to have you on Dev Show. So let's jump right in and get to know you better. So what do you do in your professional life?
Yeah. Right now, I'm actually working in Orsted as senior application architect, and I'm mostly architecting the way how we ingest data from the vendors. So, and our vendors are more likely about the wind power vendors like Siemens and Vestas, things like that. So I'm actually assigned as an architect into that area. And of course, right now I'm also doing some development in the company, but mostly it's more about architectural.
Cool.
Yeah, fantastic. And you mentioned that you authored that RepoDB RM. Oh, sorry, ORM. I'm not a .NET developer. Sorry. So, so maybe can you tell us a little bit about that? Are you often contributing in open source in general?
Yes, that's correct. RepoDB is a hybrid ORM. It's something like an existing ORM we have in the market, like Entity Framework and like Dapper. They're very popular. So the RepoDB is same as that, but it's just new, and actually authored that one, and it's very new to the community for now. And we are trying to do our best as well to have it, you know. Available and used by the community for the upcoming years. And yes, that is how it is about it.
That's amazing, Michael. So you call yourself a pretty good stock trader and investor. So I like to invest as well, and I like to get all the good tips and all the good edges that I can get. So share with me your secret. I know it will be shared with others, but
Yeah, that's true. I actually been in a stock trading for more than I guess 8 years now, almost 10 years. And then I'm doing investment, but not here in Denmark. It's in the Philippines because most of my account is actually in the Philippines, and I think it's hard to bring it here in Denmark. And yeah, of course, I have techniques to win more on trading and investing, and it's a bit maybe risky, but I can show it to you if you would like to.
amazing. I think we
Yeah.
should take this in a separate one, but I would definitely like to talk to you about that.
So I am not very much into investing, to be honest, but I consider myself as a selfie queen, and I heard that you are a selfie king. So maybe you can tell us that about your experience, and then is
Yeah.
there any important people that you took selfie with?
Yeah, that's true. I've been to some major events of Microsoft in Seattle, like Microsoft Build and Microsoft Leap, and I just saw these, big guys from Microsoft like Mark Russinovich, and then Azure CTO, and then also Scott Guthrie, and the creator of C Sharp as well, Anders Halsberg. So I did actually selfie with them after their session. So I just went to them and you know what, it's my opportunity. Can we have a selfie together? And I just asked somebody from the audience to just take a picture of us together and also do a selfie by my own. And that's true.
Oh, oh, that's
Yeah.
great. So I can say that you are much better than me in timing and using the opportunities. I actually shared it with Rasmus earlier that I was at the conference where Steve Wozniak was there, and we were just waiting that all the speakers take the selfie with him. And then at the time that he came there, I was not there because I went to pick up some cakes. So everybody, so many people actually took the selfie with him, but I was not there. So, but the cake was good, at least.
Very good story. So good to know. Good to get to know you better, Michael. And we look forward to for you to deep dive into your topic today. So let's Sherry and myself go in the background and leave the stage to you. So we will share your screen on stage now and go in the background and take it away, Michael.
Yeah. Thank you so much. Can you now see my screen?
We do.
Yes, so good afternoon, everyone. The topic for today will be RepoDB, a hybrid ORM library for .NET. Let's start with the basic and to know about what is this ORM. RepoDB is an open source .NET library that bridges the gaps of micro-ORMs and macro-ORMs, also known as full-ORMs. It helps you simplify the switch over when to use the basic and advanced operations during the development. What are these gaps that I'm trying to say here? This are actually the methods and features and capabilities of the ORMs that you are trying to use when you are doing the development, and also design and or architecture when you are trying to make a solution in yourself, how this ORM impacts your designs in your applications or any other means as well, etc. And why is this session important to you? This is to provide you the detailed overview of the features and the functionalities of the library, and also to give you the knowledge about the different capabilities of this ORM, because it will help you solve the real-world complex edge cases in relation to the data access space in .NET. Let's go about how is RepoDB differed. So I'm trying to benchmark RepoDB from both Entity Framework and Dapper on this tutorial, at least for this session. But I would like to make a disclaimer on it that I'm not putting RepoDB at the same level as Entity Framework and Dapper, but they are only just a baseline when it comes to the features and also the performance and efficiency of the ORM. So Entity Framework, developed by Microsoft, a full-fledged ORM, and almost has everything. Dapper, on the other hand, developed by Stack Overflow, That is the most lightweight ORM in the market, and you need to issue a SQL statement at all times. Whereas RepoDB mediates the developers mostly need features from both Entity Framework and Dapper ORM, and that's on purpose. You can open a connection as simple as Dapper and execute the operations as simple as Entity Framework. And both RepoDB Core and Dapper are considered the bare metal ORMs, so they are almost identical on the way how we utilize this library. Supported RDBMS or relational database system of RepoDB is SQL Server, PostgreSQL, MySQL, and SQLite. And we are also using different drivers for that in order for us to be able to work with on that RDBMS. They are all supported by the author, and I'm actually collaborating with them. Features available in RepoDB are below. So we are supporting asynchronous operations, bulk operations, caching second layer, class handlers, connection persistency, dynamic operations, expression trees, fluent operations, explicit and implicit mapping, inline hints, multi-result set query, property handlers, repositories, statement building, tracing, transaction, and type mapping. We are a bit limited in time here, so we are only choosing all those standout features of RepoDB against any other ORM, and we have chosen these 6 features that we are going to display and demo to you guys, at least for this session. And we will going to explain each of those features that we are going to demo to you today. So batch and bulk operations, this allow the users to execute multiple records at one time. It's a proven solution to data access performance problem for most enterprise applications. Batch is a concept of executing multiple single executions at one go, whereas the bulk is actually a concept of covering all the desired information in the execution at one go. It can execute multiple million rows without having the performance being affected that much. And the next features that we are going to show to you is actually the caching, and the second layer cache, as we called it. It allows the users to temporarily store the data into the memory of your computer or any other caching storage, like file caching, for example. You can create your own object there. You can also utilize the mem cache if you would like to, or you can even use the localized database like SQLite. Any other means of caching, you can actually utilize that in RepoDB. You can just simply inherit the iCache interface and implement all your means on that area. The next features we are going to explain is class handlers. So this will enable the users to handle the deserializations and the serializations or hydration process of the model. Think of the fact, for example, that you are reading the data from the database, and you would like to handle the way how you read the data from the database, intercept the informations before you send it back to the client, and vice versa. If you are sending an information towards the database and you would like to validate that the information is correct before you save that one in the database, class handler is a perfect features for that. You can actually handle such kind of things. And also property handlers, the next features. Earlier is a class handler, but in this case, property handlers is actually based on the property and the columns of your table, property of your model. So it enables you to intercept the serializations and the deserialization process of your class properties. It's the same goes as class handler earlier, but in the level of property. I will gonna show it to you later how they are different during the actual demo coding we have. And then the next inline features we are going to show is the repository. This is allowing you as a users to organize and simplify the implementation of the data access layers. In RepoDB, we are supporting 2 repositories. We call it DB repository, used for implementing a dynamic repository. And the next repository is base repository. This is used for implementing an entity-based repository. Base repository is usually used, for example, that if you would like to use to process single model or single table against the database, like entity framework, set, DB context, for example, base repository is equivalent to that, but it's much more lighter and simple, maybe in the way how we implement this one. And the last but not the least features that we are going to show today is actually the tracing capability in RepoDB. It means that it allows you as a user to debug and trace the actual execution of the library. It's actually gives you the possibility to see what are the SQL statement being executed, what are the parameters and arguments being passed, the time of the executions, how long is the executions, things like that. And maybe something like that, if you would like to cancel the operations, if you think that is something malicious, or you think that is actually not in compliant with the security, for example, then you can just simply cancel those operations. That's for tracing. And why I use RepoDB on top of, or maybe something like against any other ORM, it's actually generally very fast in fetch, save, delete, and update in all push and pull operations towards the database. And it has an out-of-the-box support for atomic, batch, and bulk operations. It is very efficient in memory usage. It is very lightweight, no change tracking, no extra calculations. It's hybrid, easy to switch between massive and micro operations, and the only identified ORM in the .NET that support this fast switching capability, at least as I currently speak to it. And it only takes 10 seconds to install the library, maybe a few seconds. But I would like to make a bit highlight on this lightweightness and the no change tracking, no extra calculations. It means that we are putting still RepoDB in a space of being a micro ORM rather than a big ORMs. So even though it's actually a bit hybrid, but still very, very micro and bare ORMs if you are going to use this one. Yes, so let's dive into the demo about how are we going to use the RepoDB. Here, I actually created a very simple web API, REST API applications. And on these applications is a C#.NET 5, and I already have created the objects that is needed for these applications to run. But I will going to explain it one by one today in this demo for you to be able to capture all the informations needed to work with RepoDB. So here, I already have installed the RepoDB 3 packages, the RepoDB package, core package, RepoDB SQL Server, and SQL Server.bulk operations package. So they are needed in order for us to work with a SQL Server database and also with the bulk operations for the SQL Server. And I will also start working with maybe some explaining about the interfaces. So here I created a very simple interface iRepository that accepts one generic type of class, and it's actually have this CRUD operations, which is save, delete, update, merge, get, and get all methods, the one that we will be going to use later. And here I also have created a model that will be utilized on this demo. I call it person model, a very simple person model. It only has an ID, name, properties, address, and created date UTC. And this is actually equivalent to what we have in our database. So in this demo, I already have pre-created the database for this session. And we have a database demo RepoDB, and we have a table called person, which has 4 columns as well, equivalent to what we have in the class here. We are not going to utilize the mapping in these sessions, but eventually you can utilize the mapping if you have different column names or maybe table names when it comes to naming. And then I'm going back to interface. I also created an iPerson repository interface that implements the iRepository interface we have explained earlier, that is only dedicated to the person model, as you can see here. And then I also created what we call repository, the one that utilized the RepoDB person repository. And then as you notice on this repository, I have actually inherited the base repository object of RepoDB, and I passed the person model in order for us to just work with the person model. And then also the SQL connections, which is actually the actual connection object we will utilize to connect to our data store, to the database. In this case, it's SQL Server. That's why we're using the Microsoft.data, that SQL client, that SQL connection. And also, I had implemented the iRepository interfacer in order for me to just simply inject this one later in our controller, and also going to just simply implement the operations needed for us to be able to make this repository works against the database. When you implemented the base repository, immediately you will inherit all those features needed from RepoDB. These features you can actually insert, you can actually do the merging, you can actually do the update, and then you can also do something like an insert all, which is the batch operations, and also merge all, which is also the batch operations. But for now, what we're going to have to do is to simply utilize the method that has been inherited from the base repository. So for delete, we utilize the delete operations. We just simply pass the primary key. For the get, we just utilize the query. You can also do it like this, like entity framework if you would like to, expression-based approach. For the get all, which is returning all the entities from the database, we just utilize the query all. For the merge, we just utilize the existing merge method of RepoDB. And then you have a qualifier name. I mean, the qualifier fields here, which is actually equivalent to the name for now. But in any case, you can always utilize multiple fields as your qualifiers. You can do it like this, or you can just simply do it like SSN, for example. If you would like to do it like that, then it's actually also a good qualifier for that. In this case, on this demo, we are only utilizing the name. And also for the save, we call the insert, and the update, we call the update method, as you can see. And now I'm going to showcase as well that during startup, what we're going to do is a bit important. When you are ready actually with RepoDB, all you're going to have to do for that is just to call the initialize method of the bootstrapper class of RepoDB. So for SQL Server, it's going to be SQL Server Bootstrap. For MySQL, it's going to be MySQL Bootstrap. For Postgre, it's going to be PostgreSQL Bootstrap. And then just call the initialize method. And all the necessary context that is needed to work with that database will be loaded up by RepoDB for you to be able to work with against that database. And as you can see here, as I showcased earlier, I am connecting to my local machine. I'm connecting to the demo RepoDB database and using integrated security because I am the owner of that database, at least for now, as I speak. And as you can see, it's the same database as what we have here in our SQL Server. And I'm going to inject a singleton repository in this demo, and I'm utilizing the person repository earlier, the one that I created here. And that's how it is. And we just registered everything. We created the repository, and then I'm going to just run this for us to showcase what's going to be behind this API. And while actually it's running, maybe we'll just wait for it a little. So the Swagger methods has been loaded, at least for this one, and all the operations needed for this has been loaded. So maybe I forgot to show that we have controllers here. On this controller, we injected the iPerson repository, and then this controllers contains different methods, and its method is actually calling the necessary method we have developed in the repository object. We have delete, we have get all, we have those get operation, we have save, we have merge, we have update operations, and it's a very direct controllers, at least for this session. These are all the methods that has been created by those controllers. But on top of that, I also have utilized this Postman tool to just simply work with it rather than calling it directly from the Swagger. It's the same, but I'll just utilize the Postman, at least for this demo. So here you can see that I have already predefined those necessary methods as well on this Postman. And if I'm going to somehow save an information towards the database, you can see if we go back to the database, I'm going to select the information from the database. We don't have any records yet on the database. And if I'm going to click the send, you can see that my name is actually inserted into the database, and I have an ID 1 here. If I'm going to refresh this one, then the record is saved in this table. And if I'm going to get all, which is actually using the get all operations, in which earlier it's actually a query all, it returns all the record necessary for this. So from the database. But I also just realized that I'm actually not living in the Lungbu, for example. So I actually living in Gentov. So I can just simply merge on operations. So it means merge means that if the record is in the database, then we will gonna update that one. But if the record is not yet in the database, we will insert those record. And I'm using the name qualifier. It means that any name in the database that is actually equivalent to this will be updated. So at least that is the one that we have defined earlier in our repository. If I'm going to send this one, it was Gentov, right? And you can see that it didn't inserted new record, but instead it's just updated the existing record here. And if you're going to call something like Understuff, for example, this is a new guy, and he's also from Denmark, but is actually living in Copenhagen. You can see that we don't have the data from the database yet, right? It has been created, but it's the same record. I mean, it's the same operations we use here, but understood was created. And if you make a get all towards this one, now the two information has been returned by RepoDB, and that is how it is actually when it comes to the CRUD operations when you are implementing a repository. I'm going to stop this one because we will gonna demo the next features of RepoDB. The next feature that we will going to explain is actually a caching. So if we are going to go to the website of RepoDB, caching is actually a concept that we first when you fetch a record from the database, for example, you need to make sure that if the record you are fetching is actually not frequently changing, or that is something like a static records, then it's good for you, or you have an opportunity to cache it on your local PC or in your computer memory. So RepoDB, on the other hand, what it's doing is something like to check whether there any cache record from the cache storage. If yes, it will return back to the client. If no, it will try to get the information from the database, cache it back, and then return back the information to the clients. So that is what actually the caching is doing. In RepoDB, query, execute query, and query all methods, they are all cacheable. And in order for you to just simply cache the information, there is what we call cache key argument when you call these operations. And then all you're going to have to do to this is to pass the key for your caching. And once the key is actually there and has been called by RepoDB, RepoDB will gonna cache your information in the computer memory by default. RepoDB is using the my-RepoDB memory cache object. That is not the .NET object. It's actually customized in RepoDB in the purpose of its method needed, at least for the framework. And here, when you call this one, these operations will be cached into this cache object. And you can always call the repository cache object to just somehow purge the information, like clear the information. You can also add a new cache for that. You can also remove or get the existing cache if you would like to. But just to let you know that if you are working with a repository, RepoDB will handle everything for you. Not in the case that if you are working with the connection object, then you have to pass the instance of the cache object every time you call the get or fetch operations. So let's say, for example, we call the get all, we cache the information of people in our client, and then I'm going to run this one. And I'm going to call the get all operations. So you can see in the database, we have 2 records, right? And if I'm going to just send this one, now I get the information from the database. But this time, this information is cached. You can see that it's actually 833 milliseconds when I call it, right? But if I'm going to run it again, you can see that the time is very fast. It's 11 milliseconds. And if I'm going to run it again, it becomes 10 milliseconds and 8 milliseconds, because the next query is actually from the cache and not from the database. And how to prove that one? I'm going to truncate the table from the database. So it means that there is no record anymore in the database, as you can see. And then I'm going to run again this, and then it's still returning the information. The cache is actually still there. The cache will be invalidated for the next 3 hours or 180 minutes. And as I mentioned earlier, if you have a requirement, for example, to just purge it, simply call the cache the clear method, and everything will be cleared for you if you would like to just do it. So we will not gonna handle the auto flush of the information of the cache. It's up to you to handle that. Yes, and the next features, I mean, this is actually the cache features, and the next features that we are going to explain to you is actually the tracing capability of RepoDB. Tracing is actually a feature that would allow you to see or intercept the actual executions against the database. In RepoDB, all you're going to have to do is to just simply create a class and implement the iTrace interface. This iTrace interface contains all the after methods and also the before methods of all operations that is available from RepoDB, in which the after methods is actually being triggered after the executions of that method, and the before methods are being triggered if before the actual executions of the operations against the database. And as you can see here, I have implemented all of those, and I can actually make a breakpoint in the after insert and maybe after query all, and also before insert and before query all to showcase to you this capability. And once you had implemented your customized tracing or whatever trace object you can have, all you're gonna have to do is to just simply inject it in the repository. So as you can see, when you try to inherit the base repository, there are different constructors available. So you can pass the connection string and also the connection persistency, cache object, statement builder, your tracing object, which is the one that we just created now, command timeout, and any other objects, parameters here. You can even pass all of them together if you would like to, if you have a customized things from your end. So at least for this case, we just simply pass our own custom trace. Yes, so I just passed this custom trace, and then I'm going to use in this tracing in the upcoming operation call that we have. And I also would like to say that you just make a dependency injections in your actual implementations and inject it here rather than to utilize the object instantiations. I guess dependency injection is much more formal in the way how we implement the things here. But for now, we'll just utilize this object instantiations approach, at least for this demo. And I'm going to run this one. And then again, I'm gonna call the save operation. Here you can see I'm gonna save myself again. We don't have any record yet from the database, and then I'm gonna save this operation again. As you can see that before insert has been triggered, and you can see here that as well that the actual SQL statement is actually available for you. There's a session ID in which the session the same you will gonna use when you are trying to reference this one in the before and after insertion. The parameter model, which is actually the one that you just passed from your client applications, and also execution time. And the good thing for this is that during the before, you have an opportunity to cancel it if you think this is a malicious call. You can actually something like do if flag that statement that contains delete, for example, then you can actually just simply lag that, cancel it, and then throw the exception back to the caller, and then it means that during the insert you can't inject any other operation except for the insert operations and things like that. And now I'm going to run this one. As you can see that the after insert has also been triggered. That's because after the insertions of the data from the database is the same SQL statement. It is the same session ID. It's the same parameter, but you can see that the ID has been set back because this is the generated identity from the database. And you can as well see that the execution time is very, very fast. It's just less than 0.2 milliseconds, things like that. And it showcases to you this execution time. I'm going to run this one. And then also something like call the get all operations. And then also the query all has been triggered. As you can see, the same statement, the same information as what we have before. We have session ID, things like that. And I'm going to run it again. You can see that the after query all has also been invoked with the statement and also the execution time. And also the results here is actually the entities that has been created back from the database. The same session ID can be utilized earlier before query all operations. So that is actually the tracing capability of RepoDB, in which I guess it's a good features that is available from this ORM, mostly not supported by the other ORMs maybe, but here in RepoDB it's actually out-of-the-box features. And the next feature that we are going to explain is actually the class handler. And here I again pre-created a very simple class that implement this class handler interface in RepoDB, just to beat the time on this demo. So all you're gonna have to do is create your custom class and then implement the iClass handler interface and just pass the model that you would like to handle. And as you can see, when you implemented this class handler, you will have two methods, get and set, which is actually the set is the one that when you're trying to push the data to the database, like delete, insert, merge, and update, they're actually pushing the data, this method will be triggered. You can intercept the informations. So you can always validate the informations there before you send it back to the database. Whereas the get operations is actually the one that when you get the data from the database during fetch, like query, query all, and execute query, then you can actually harmonize the information because you can intercept that, or maybe you can verify it against the attached DB data reader object here, or validate the information when you send it back to the client. And I can show it to you later. But here you can see that DB data reader is an object where the position of that object is actually equalized to the information we are actually hydrated into this entity model. And once you have the class handler implemented, targeted that model, in your model, all you're going to have to do is to just simply create what we call add an attribute called class handler, and then pass the type of your class handler, the one that you just created here, and then do it like this. Just decorate this attribute, and eventually RepoDB will gonna use this class handler towards that model. So I'm gonna run this one again, and then I will insert an informations towards the database. And here I'm gonna save information called again honors staff. He is actually from Copenhagen, and I'm gonna insert this one. You can see that RepoDB tried to intercept that when you implemented the class handler. And as you can see here in the entity model, you pass from the client. These are actually the values that you have passed, and then we decorated what we called the name when we save it to the database is something like understop colon handled, and then return the entity. So even actually we passed the information understop, but the one that has been saved to the database is actually understop handled, as you can see here, right? And now if we are going to query the information from the database, as you can see, I would expect we will gonna return these two records from the database. But you can see that it's also being intercepted, and you have an opportunity to harmonize it or validate it or something like remove this handle. So for here, example, the first record is my record, so there's nothing to harmonize or validate towards it. And then I'm going to run it, and then the second record is actually the understop record, which has the handle here. And here we are actually removing those handled. Even though in database we have those colon handled, and then the one that we return in the client is actually correct because it has been intercepted by your class handler, but the one in the database has a handled actually. So this is actually the class property, which I guess is a bit important as well in some cases, in your case to utilize it. And then the last features that we're going to explain here is actually the property handlers. So again, I've also predefined here, but this is a bit different from the class handler, although the concept is the same. On this demo, I'm going to showcase to you the way how we actually handle the conversion of object and string object. In which case, for example, we have a person model, and I would like this person model to have a complex type when it comes to its property, but eventually the information we have in the database is a string, right? So we're gonna save this one as an object into the database, right? But we will gonna handle that one. And how are we gonna do that is when you handle that one, you just have to create your class object and implement an iProperty handler towards it, and then define what is actually the type of your database and what is the type of your properties. This is the model properties, the address type. And once you have implemented that one, you will again get, you have two methods called get and set method. And this method will be triggered based on your actions against the database. So set method is actually the push method towards the database, and the get methods will be triggered when you are actually pulling the information from the database. So it's very simple in this case. We can see that in the set, we just serialize the object as a JSON using the Newtonsoft.json library. And here in the get, we just simply deserialize it back to become an address object. So I'm going to showcase to you how it is actually being handled. I'm going to first truncate the information from the database so that showcase to you that we don't have any records there yet. and then we're gonna utilize this property handler. So in your person model, once you have already defined those property handler, all you're gonna have to do is just simply call the property handler and decorate your model, and then type of your property handler, sir, and then property handler object, and then just simply run it. RepoDB will handle both of them. So just simply run it, and then when we run it, actually, and when we try to insert the information against the database, let's say we're going to save the information towards the database here. So I already prepared some object, actually, so that I will not going to type it from scratch just for this demo. So you can see. As you can see here, I will explain. In the address model, we have street, postal code, and country. This is a bit complex than what we have before, a direct to the point static string. And in your model, you are also inserting it like something like country is Denmark, postal code is 123, and this is your street where I'm living. And if I'm going to send this one, this object will be passed accordingly. As you can see here, this object has been passed here, but the one that we are going to save into the database will be converted back to string. If I'm going to run this one and query the data back from the database, you can see that the address is actually saved as a string object. So imagine the fact if you have a scenario that you have a system from legacy system that has an XML object, you can utilize these property handlers, and then you can just simply deserialize those back to become an object to your client. And then vice versa, if I'm going to make a query from the database, the get operations is also being triggered. And as you can see, the information we retrieve on the database, we just deserialize it back to the address object. And then that will be set back to the model. You can see during the hydration process of this model properties address, it has been set back. And then you can see here. And then if I'm going to run that, you can see that the address has actually been set to a complex type address model from our applications. So this is it. I mean, it's actually in these possibilities when you're using class handler and property handlers. You can actually handle something like making sure that when you are sending the data to the database, UTC type of your date fields, for example, you need to make sure that it's a kind of UTC type, and also money conversion from or something like a string to integer conversion. You can also handle that. You can trigger. You can react from any trigger from any models, and you can also set the value of the other properties in the class handler. So we have a lot of scenarios being handled, but at least in this case, I just showcased to you a very simple scenario that we can handle using this class handler and property handlers. And of course, there is also possibility that you guys don't like to make a decoration in your class, right? Because you see that, you know what, it's actually, we're using multiple ORMs, or we just would like to make sure that our model is just clear and it's actually not being bound to a specific ORM. So you can remove those. And in RepoDB, we support the fluent mapper. So you can also utilize something like the fluent mapper object of RepoDB. And then from that fluent mapper, you can just simply call the entity, and then your entity is actually your person model, for example. See, like that. And then you can utilize the class handler. Here in the class handler, you can just pass your class handlers earlier, the one that we have created. And also you can just simply put the property handler if you would like to. So something like that, and then the property handler here, and also something like you know what, this entity is actually not from the DBO, but it's from the sales that person. So that's actually the table name, and we can also change the column, things like that. So that's actually the fluent mapper. It's the same as what we have before in the decorative approach in the model. But instead, you're just removing all those possibilities and just make it more declarative in the way how we implement the things. And that's how it is actually for these property handlers. And last but not the least, actually, is the batch operations, which we will not gonna showcase to you the actual operations in actual, because I think it will take time. But I can showcase to you the high-level concept of what's actually happening on that batch operations. As I mentioned earlier, when you are actually inheriting the base repository, the insert all method, the merge all method, and also the update all method, they are all batch approach. They are batch operations. It means that it is capable of processing entities here. And we are talking real batching approach, not actually an atomic approach. So it means that you can actually also set the batch size for that. And that is actually the number of records we are sending from the client applications towards the database. If I'm going to make it an explanation on top of it, here, batch operations. So as you can see here, if you have a client applications that uses RepoDB and you have 100 entities to be inserted towards your database, and you set the batch size to 30, it means that RepoDB is actually do a connection to the database 4 times. It means that the first 30 entities will be set, and then also the second 30 entities for the second batch, and the third entities, 30 entities will be third batch, and then the last 10 entities will be the fourth batch. Imagine the fact that if you are actually not supporting the batch operations, it will be 100 iterations, and it will take 100 connections towards your database to just open it up or something like close it up and then insert the informations. Although you can utilize also single connections towards it inside the iterations, but batch is much more robust in that situations if you are actually inserting multiple records rather than doing it one by one in atomic approach. And all the informations here is actually wrapped with the transactions, and they are all acidic. It means that they are actually they are acid in nature by default. And the other thing is actually the bulk operations, as mentioned earlier as well. The bulk operations, RepoDB have it as out-of-the-box feature, so you can actually bulk delete the informations. We can also bulk insert. You can bulk merge. You can bulk update. They are all given, and it's a bit more advanced concept in RepoDB because this is something like utilizing an approach that is actually not being supported by the framework and the database itself, but we just develop the concept in RepoDB in the way how we actually implement these features. For example, when you have multiple informations from the client and you call after the bulk insert operations, we are utilizing the SQL bulk copy, the write to server method as well. You can see here, but there is a possibility for you to get the information back. I mean, the identity in which is not supported by the default bulk operations. And RepoDB is a bit highlighted features because there might be a possibility that if you are inserting 100,000 rows, for example, but I really would like to get back the entity back when I actually inserted it, you can do it in RepoDB. All you're going to have to do is to simply set the sReturn identity to true when you call the bulk insert operations. And that's the thing. I mean, also in the merge, in the bulk merge, bulk update, you can also set the batch size and also set back the return identity if you would like to. It's as simple as this. When you call the bulk insert, you pass the list of the entities here, and then also sReturn identity, and then just to true, and then it will return the entities back to these entities that you have inserted. And it's important to take note that the alignment of the entities towards your model is actually being validated. There is a bug towards that, but we have actually fixed those problems that when you do the bulk insert, write to server method is actually not aligning it properly, and then we found this problem in RepoDB, and then we created those fix to simply align the generated identity towards those the model that you are inserting against the database. And of course, I would like to as well highlight that you can visit repodb.net always for you to be able to work with the library. It will be you can actually go to get started now, and then it will guide you on the way how you use the library, and also there's a lot of things there. All the methods, all the features we have in RepoDB is well documented on this website, so you can see all the features there, like hints, for example. As you can see, when you make a query all, you can pass the hints, or you can also utilize something like the SQL Server table hints class for you to be able to just whatever you would like to change the isolation level. And there's a lot of things here, actually. All operations is also documented here. The classes, attributes, and also would like to highlight the references. I mean, references is the way how you guys would implement the things when you're using the library. For example, unit of work is not a default thing in RepoDB, but you can actually leverage this approach of unit of work if you are going to implement that on your own case. So this is our recommendations. And of course, it's your perusal. You can also implement your own on the way how you implement the things. But this is just an example, that reference for you to be able to utilize. And also releases. So if you are actually on top of this package, for example, every release that we are updating this releases sections, and also the blogs, as you can see here. So major releases, we are creating a lot of blogs for that, and then you can actually follow what are the changes that we made on the version of RepoDB during that major versions. And also don't forget to give a star on our project. Yeah, it's a great support for us. So just follow this project, give us stars toward it, and also utilize it, and then share it to your colleagues if you would like to. And also earlier I mentioned to you, it's also good to highlight during this demo that we utilize the raw data access venture of Franz Boma, the creator of LLBLGen. In which actually on this result for the last 2.5 years, RepoDB is actually the first ORM that only just ran behind hand-coded materializer. But when we actually tried to update it in the .NET 5, RepoDB also beat the hand-coded materializer, in which it's impossible to beat this one. But Franz Boma also tried to investigate why RepoDB beat it. But I saw as well and shared to him the technique on how to maximize the ahead of time compilation of certain anonymous object. That's why RepoDB beat it. So, but right now at least RepoDB is actually the first in line here in the venture. And it's also like to highlight that the efficiency of this library is very, very efficient. It's using very, very low memory in all operations. So at least for this get operation, it's very, very low, and it's a good thing. And also I still have 2 minutes left. And also would like to highlight that that Scott Hanselman actually tried to promote RepoDB as well to the community of .NET. So he created a blog, and maybe it's also a good thing for you to start with to read about it. And here he actually highlighted the second layer cache of RepoDB, in which actually being may be useful in some use cases, or maybe most of the use cases that you can implement in your own applications. And also last but not the least is also the adaptation of this library. So for the first 2 years of development, we don't have any much more download, but starting last year when we tried to open it to the public, and also Scott Hanselman when he tried to promote this one to maybe something like recommended this one to the community, they're not really promoting. There is a lot of downloads in RepoDB happens there. It's actually multiplying the downloads. It's more than 80% from that time up until today as I speak with it. That is actually all on my demo for today. And of course, do not forget to the references, sir. You can always follow me in Twitter to get the latest update of RepoDB, although I'm not that much active in Twitter, but you can always follow me to get the latest update, and you can tweet me anytime. Yes,
Amazing.
questions.
Thanks,
questions.
Michael. So always amazing to feel the passion of somebody using something, right? So, and I felt that with this presentation, and always amazing to see live coding. So we have a couple of questions here. So the first one you might have answered after the question came in, but Jacob is asking if RepoDB can handle other than single entity to table objects, for instance, saving complex objects to multiple tables.
No, I'm actually expecting that questions. RepoDB is not supporting deep object graphs and relationships, but it's always a good thing to know that RepoDB you need to just do it manually. Unlike entity framework, that if you have these relationships, they will be solved automatically. But in RepoDB, it's not. So you need to handle it one by one because RepoDB is actually a direct table-based approach, ORM.
Okay. And then we have Adi, +10 for cache, bulk, and batch operations.
No, thanks. Thanks. Yes, and
And
don't forget to just contact me anytime about it.
and then we have Jonna. Interesting to learn about RepoDB. Are there any important pros and cons of using RepoDB? Quickly here at the end.
Yeah, I forgot to share it earlier. But anyway, maybe I can highlight this one as well. There is a limitation page in RepoDB GitHub page, as you can see here. And then maybe in order for you to maybe just read this page first before you use the ORM. Okay, and here we are trying our best to explain to you what are the limitations. And so here you can see that computed columns, composite keys, there are join query, and also this is the deep object graph approach, cache invalidations, advanced query tree expressions. They are all limitations in RepoDB, although we have an alternative towards that in every scenario here, but we have an alternative solutions, but it is good for you to read this one, I would say.
Good point. Thanks, Michael. So, yeah. Thank
Super.
you very much for the presentation. Please hang on the last couple of minutes, and I'm sure Sherry will share something about the Azure Heroes program.
Yes. So for all of you out there, you can scan this QR code and then follow up the instruction to get your winter learner. Even though that we are getting to the summer, actually to the spring, but still it's good to have a warm cup of hot cocoa. So scan this QR code and then you will get it. For you that you don't know what actually Azure Heroes is, I always describe it as a token of appreciation from Microsoft to all of you for learning and building on top of our technology. And we have more than a learner badge. One of them is actually open sourcer badge, which we are always awarding that to the people that they are contributing and maintaining to the open source. And I believe we have a very good candidates here. Michael. So thanks for all your contribution to the open source. We are going to send an email to you afterwards with all the instruction to get your open source badge. Thank you for that.
Thank you so much as well.
Yeah, welcome. And also you can go to this URL and learn more about the project, and also you can nominate yourself or your friends for some of the different badges that we have out there.
And if you have questions, you can always reach out to Sherry. She's more than happy to talk about it. So we want your feedback. One more QR code. So if you go to the feedback form that we have, ping us on Twitter, ping us on any platform. Both Michael want the feedback for this session. We will share it with him afterwards, but also for the future, how can we improve this dev show? So give us your feedback. And I know that Sherry is also handing out gifts to one of you who is filling out this form. So there's always swags to get from filling out the form. Well,
yes, that's true. We all love swags. And I want to mention that tomorrow we have Maker Show with Sarah. If you're into the IoT and AI, she's going to present a really cool project there. So you can go to aka.ms/Maker Show and you can find the description. Actually, if we can find out how you watch that. And then we have to say that actually next week we are skipping the show because we have Microsoft Ignite, and I expect that majority of you are going, even though that I know you all love us, but I'm pretty sure that you're going to prioritize Ignite
not
over
that much.
unless you're really insisting. No, just joking. So we're all looking forward to have Microsoft Ignite as well, and then we will come back to you on 9th. And also, since we are all here for the .NET, so tomorrow is also a focus conference for the .NET. So just follow the URL, and I hope that you all are also going to join there as well, since this is a topic. And this is my very favorite conference, actually. It's on March 8th. We are celebrating at the International Women's Day at this conference, FTW-Conf. And so please share the word, spread the word about this conference as well. And hope to see you all there as well. Also, the last things I promise is this hackathon, that is a Hack the Climate. So what is especially about this hackathon is that we reach out to a lot of nonprofit organizations that they have some challenges that they are fighting for the climate, all the challenges that we have there. So we really invite you all to join this hackathon and spend your time to work on this solution, because you all have you know how to use the technology and they know the business logic and all the issues. So I see a perfect match, and hopefully I personally really looking forward to see the outcome of this hackathon. So if you're interested in that, please actually join this hackathon. And this is
See you in 2 weeks. And yeah, be sure to check in on the meetup page to see what's coming up in 2 weeks. It's a surprise. So see you March 9th. Thanks, Michael, for being on Dev Show episode number 27 and giving your presentation. Thanks all for listening and watching in. Have a good afternoon, evening, morning. See you.
Yeah.
Bye.
See you.
Bye.